So let's talk about function scope in JavaScript. Now, you may have heard the word a closure or function scope or lexical scope, but you're unsure what they mean. So this video is here to clean up all of the misconceptions and, quite frankly, move past the difficulty of understanding JavaScript scope and what we would call a closure. Now, before we dive into what closures are, what they do, we need to understand the different types of scope in JavaScript. Now, where we are down here, let's go ahead and create a new function. And this one, we're going to say make car part ID. And we're going to pass in an ID to the function. Now, when we go ahead and call the make car part ID, we're then going to supply a random hash. So here we'll go and add some random characters to make it look like some kind of unique ID. So when we go ahead and access this ID inside of here, we can access it. Outside of here, we cannot access it. Even if we put it underneath the function, we can save this out and you can see that there's errors preventing our program from compiling. Now, if we hide our console log, you can see that over in the DevTools, we have this random hash which we've just created. So where does this tie into understanding scopes in JavaScript? Now, we can take inspiration from our failed compilation where we had this console log and we're trying to access this variable inside of here. Now, we can't do that because a function creates a brand new scope. So here throughout our entire file, this is one scope. And if we in fact created a variable up here, so let's go and say const, and for demonstration purposes, we'll say another ID equals 1234 ABCD. Now, the interesting piece with JavaScript is the way that a scope chain works. So here is one scope. So let me annotate these. So we can say scope number 1. Now, inside of here, we're technically doing scope number 2. Now, in scope number 1, we just found out that our ID cannot be accessed outside of scope 2. However, if we decide to take our another ID and add it into our console log, you'll see that we can now talk to variables which exist outside of this scope. So this is one scope, and you can think of this as a nested scope in between. We can absolutely go ahead and say function, another function, and this will, as you may have guessed, create a scope number 3. If we were to create a constant called SumID and give it the value of perhaps 99, we cannot access this outside of here. But, however, we can access, if we bump these down, we can access all of them inside this another function. So we have scope number 1, anything which is essentially a parent scope. So this is a child scope and another child scope. This scope can look at this scope. This scope can look at anything in this scope. And if it's not available, it might look up to the next scope to see if something was available. So what do I mean by not available? Let's say we're going to have some ID and we'll just log this out here. Now, we could have another some ID and we could have some ID as well. Now, if we try and access it down here, this is actually going to look in its current scope chain first. So the interesting thing is we have a red underlines here saying it's declared but it's never used. Now, this one isn't red because we're using it in scope number 3. But if we were to essentially hide this value, we then look at this scope. And if we then hide this value, we then get this particular value. So you can see that it will look in its current scope and then go up the scope chain all the way to the top. And if at that point it doesn't exist, it's then going to throw an error. So you might want to call these local variables where they're local to that particular function. And through this demonstration, you can see that in different scopes, we can access anything that's available in the parent scope. So let's get rid of this, and I want to show you how we can think about JavaScript closures, because that kind of answers the entire question. So let's assume that we are making some kind of car part ID, and this is going to be a prefix to perhaps a left door and a right door. This is like some particular paint code, or it could be a model or a part number, but we want to prefix it once and only once. We don't want to keep adding the same thing every single time in a hard-coded string. So let's go ahead and we're going to say const the ID equals. Now what we're going to do is say car part, and then we're going to interpolate that value and pass in our ID. Now if we go ahead and return the ID, we could go back to where we make the function call and say car part ID equals, and then we're going to call that function. So all we're doing here is simply returning something, and we'll expand this momentarily. So let's assume we are now using this unique ID, and this is tied to a specific car. So now we want to register the fact that it has perhaps a windscreen and a left door and a right door. So how could we do this without repeating ourselves every single time? And this is a good use case to demonstrate the concept of a closure now that we've understood what scope is. So we have one scope, two scope in this current example. So what if we introduced a third scope, and instead of returning the ID, which is just a string, we returned a function instead. So let's go ahead and say function, and then inside the function, we're simply going to log out the ID. So let me go ahead and save this out. Now you can see that our console has completely changed now because we're returning a new function. So the make car part ID has in fact invoked this function. The car part ID at this point in time has definitely been created, but we're not doing anything with the variable. We can't see that the variable has been created. And we can confirm that the car part ID has been created. We can say created and then interpolate the ID. So here we're going to see we've created that car part, but we've got a function. So something else is happening here. Now the idea of this scope chain and the idea of closure is that this function essentially closes over the variables here. So even though we've called this function's still waiting to be called, but it has access to this variable. Now, if that doesn't make sense, let's go ahead and complete the puzzle. Now, the interesting piece is because we're returning a function here, we in fact want to go ahead and call it again. So let's call a function which is returned from this function. So we've got one function, two function, we're calling the function here, and again we're calling the function here because remember, this function is returned to this variable here. So this variable now contains this function now, which has access to the ID. So when we go ahead and call it, we'll then see our car part and the word undefined because we're not returning anything to this function just yet. So that means that we might want to now return, and we'll create a new string for this. We'll interpolate the existing value, so we'll pass the initial ID in, but we're going to extend this underscore syntax where we're just going to label the part number, and we're going to supply a part name. So we're going to take a name, and what we'll do here is call to uppercase just to make it more of a functional example. And then finally, we can add name as a parameter to our function. Let's go ahead now and create a left door and save things out. So now we see our car part, it's been prefixed, and we also have the left door. So at this point, you may be thinking, okay, this may seem like a bit of a strange way to do things, and what benefit do I get here? Now the benefit comes from when we want to add perhaps a right door and perhaps a windscreen. So let's save all of these, and immediately you can see that all of these car parts have the prefix that we want, followed by their descriptive name. So we've had a pretty successful mission here, and we've created that unique ID once. This could be for the specific car, and then we're going ahead and stamping the same thing out. Now the interesting piece is this function, the make car part ID, is just called once. We're invoking it once, whereas because we have a returned function, we can call it as many times as we want, and we can call our make car part ID as many times as we want as well. Now to demonstrate how this is nice and useful, we could go and create another hash, so we'll do some random characters as well. Now what we could do is rename this to another car part ID, and then we'll go and change our function names. So when we save this out, we're going to see the same part names, but they've all got individual hashes which are different. So this has been a really good example of how we can create and essentially freeze in time after we've called the function once, the variables in that particular closure. And when we call the function again, it saves that variable in a particular scope. In this case, our make car part ID. It has its own child scope with a local variable. And because we've now understood that functions can access variables above them in the scope, we have full access to it. So every time we call this function, we can then go ahead and prefix it. Now, if we wanted to, just for example's sake, we'll also convert this over to an arrow function just to show you what this would look like. And there we go, we have the arrow function version. So you can see in this case how using an arrow function might be quite a good thing to do. It makes things nice and short. We're only having a nice one-liner. Personally, just to make sure that it's nice and readable, in this case, I would probably leave the function as this because I get that nice return statement. It's very clear that we're returning a function and then we're returning again inside of it. So that's a nice introduction to JavaScript scope. We've looked at what we call lexical scope, having that function accessing variables above it in the lexical scope or parent scope. We've then called our function multiple times with different IDs, and then using the returned functions, we've then supplied the names of the parts and they've successfully been prefixed with the IDs.